Good morning, everyone.
Good morning, sir.
Good morning, sir.
Okay, good morning. First of all, I will be taking the attendance. Franceli,
Yes, sir.
Herman, Herman Aldana, Ashby Awe,
Here, sir.
Karen Barrera,
Here, sir.
Damaris Blades,
Here.
Rachel Blanco, Rachel Blanco, not there. Okay. Shanice Blanco, Shanice Blanco. People, like I said, after I've called the roll, I will not go back. Anybody who come late, I will mark them absent. Liane Cal,
Present.
Linnell Cal,
Present, sir.
Kaylee Kamal,
Present, sir.
Brittany Kamal, Brittany Kamal, Shante Kano,
Present, sir.
Naveen Carrillo,
Present.
Kiara Castellanos,
Present.
Emily Chan,
Present.
Alanis Colendres.
Present, sir.
Alanis, you have been absent some several times. And remember, attendance play a vital role when it comes to the course. And I haven't heard anything, but probably you can see me if there was something there. Sherry Edwards,
Present.
Jense Enamorado, Jense, okay. Joanna Garcia, Joanna Garcia, Kiana Quillen,
Present.
Kiana, the same thing with you. I see some several absences and so forth. Owen Martinez, Owen, Owen, Ozil, Vire, Ozil, okay. Vire absent, okay. Aisha,
Present, sir.
Jonathan Pook, Jonathan Pook, Azale Ramirez,
Present.
Sorry, sir.
Elvis
Let me
Solis,
get disconnected.
okay. Elvis
Present.
Solis,
Present,
good
sir. Good morning.
morning. Elvis Solis, okay. Jamili Tayub, Jamili Tayub. Okay, let me go up again because I see some people coming in. When I close this attendance, Herman Aldana,
Here though.
Rachel Blanco. This is the last role I'm taking. Rachel Blanco, Shanice Blanco. Shanice Blanco. Brittany Kamal.
Here.
Jense Enamorado. Jense? Okay. Joanna Garcia. Owen Martinez.
Here, sir. Present.
Okay. Jamile Tayub. Let me close this roll now. Yeah. For the last instructional time that we met, we were addressing or we were looking at tree diagrams. How is it that we use a probability tree to solve probability problem? So that's what we are looking at. I see somebody just put a chat, but like I said before, I called the roll twice, and I've already closed attendance. So once again, we were looking at the probability tree, and how is it that we tend to use the probability tree to solve problems. By tomorrow, I'm gonna be having the list. Remember, I told you there will be 5 problems that I will be giving to you, and you must do it in the form of a booklet. So when you upload it, your work will be in the form of a booklet. So that's what's happening. Okay? Steven, excuse me, class. Steven, somebody hold it here. Okay, so like I had said before, those 5 problems, I don't know how you're gonna present them, but you need to have the problem, and after the problem, you need to have the solutions. And if you cannot use Microsoft equation properly the way that I use it, then it's best that you write it out nice and neatly and you upload the different pages. Because some people want to use asterisks and those, no. I don't want those things. I want the proper symbols, because even that will affect you. So if you cannot use the Microsoft equation properly the way that I do, then it's best that you do it in writing. And that each problem will be worth 20 marks. Like I said, and there will be a rubric which you will be seeing how I will be grading those there. And remember, I told you that I will be asking each of you to present one problem and you don't know which one it is. So make sure that you get ready, because then that will be the one that, because remember, even though each of the problems, so actually everything will be like, let me put it like 150 marks. Okay? But I'm gonna be splitting it in 2. because remember, you will need to know how to present the problems, and I will be looking at correct mathematical terminology, clarity, the problem work correctly. From the moment you put up when you're presenting and the problem you're presenting is incorrect, you will get a 0 automatically. I do not want any incorrect problem to be posted or to be presented. So if you have problem with them, then you seek help. So
Sir,
let's look at the power. Yes.
is this going to be done individually, sir?
Yeah, because since you are not there, this will be based on an individual. Because I don't want anybody to say, but this one wasn't there. Because I'm telling you straight up. Because if somebody is missing from the group, then some people might say I'm biased. Because I will just give, well, whatever zeros, so because I expect participation from each member. So apart from doing that, so what I'll be doing is just have, because you will not be taking more than 5 minutes. Each person won't be taking more than 5 minutes to present one question, because you will not be presenting everything. Only one question that I'll be asking you there. So each person may have different problems to present to the class from the set of problems that you have. So probably we might have like 5 students doing question number, just for example, number 1, 5 doing number 2, 5 doing number 3, but you won't know who you are. That's the reason you need to do all the problem, and I will put you on the spot which of those that you need to present. So that's what I'm talking about. So you need to know your content well. Are there any questions? And I will be speaking of that much more. So these are the examples that we have done using the probability tree. Once again, we must have an event so that we could, and remember, what can we say about any probability tree?
Must equal to 1, sir?
And what must equal to 1? There are 2 set things that must be equal to 1. One, the branches that meet at a point, like any point. This is 2 branches meeting, or it could be more than 2, but branches meeting at a point should add up to 1. So this should add up to 1. This is another branch, meeting at a point, add up to 1. This is another branch, we have add up to 1. Then we multiply along the branches and get our end results. We multiply along the branches. This here we have 4 branches. And if you were to add all 4 branches together again, then you should get 1, remember? Right?
Yes, sir.
We should get 1. Now it says here that mass-produced glass bricks are inspected for defects. I think we already did this question, but where? Or I didn't copy it. Did we do this question already? I think so. But where did I have it? You know, I think we haven't done it. We did it, yes, but not by means of
Sir,
not by means of tree diagram.
we haven't done it, sir.
What happened?
We have not done that. We only did the from number 3.
Yes, we have done number 3 and let me see. Yeah. We have done the one in the restaurant with the ice cream stick. So this is okay. So we're gonna be using that bricks with air bubbles is A, and C, bricks that are cracked, C, and brick that is discolored, D. It said that a mass-produced glass brick are inspected for defects. The probability that a brick has air bubbles is 0.002. Then it said if a brick has air bubbles, the probability that it's also cracked is 0.5, while the probability that a brick free of air bubble is cracked is 0.05. What is the probability that a brick chosen at random is cracked? Okay, so I'll be coming back here. Now it says here that we have outlined our event that bricks with air bubbles is A, so those without air bubble will be a complement. So let's see what will be happening here. So first of all, we're gonna be drawing our first branch. Okay. So here we're gonna be having with air bubbles A, and then here we'll be having a complement. try my best because I okay, this would be a complement. So they mentioned here that the probability, let's go back. I want to have seen that work there. Okay, it said, let me shift this before I continue. It said the probability that a brick has air bubble is 0.002. So that will be 0. Point 0 0 2. Okay. Now if that is 0.002, then what will be on the other branch? Remember?
0.998.
Okay, 0. Point
998.
9. Nine, 8. Okay. That will be 0.998. Right? Now, they mentioned that if a brick has air bubbles, the probability that is also cracked. So here we're gonna be putting 2 more branches for each. So we're gonna put a branch here. Then I'm gonna be putting another branch here. So here will be crack. And here will be C complement, meaning then that it is not crack. Again, it's right now. Yeah, so I need a good mouse. Okay, so we're gonna be doing the C complement. Okay. Then down here, I'm gonna be having my other branch before I go up there. So let's deal with this branch up here first. So it said that if it have air bubble, if a brick has air bubble, the probability that it's also cracked is 0.5. So here will be 0.5. Point 0.5. And if that is 0.5, then what would be the other branch?
0.5, sir.
Yes, because they need to add up to
One.
1, sir.
Okay, that will be 0. Point 5. Then we go down here and then it said, while the probability that a brick free of air bubble, so this is the branch free of air bubble, air complement, its crack is 0.005. So we will be going here. Okay. So here is gonna be have to try get a mouse here. It's not taking a. Zero. Point 0. Let me extend this branch a bit. Zero. And then this will be 5. So what will be the other branch? Because remember this will be C. Okay, let me label my branches. So this would have still be C. Crack. That it doesn't have air bubble, but it's crack. And here it doesn't have air bubble. And it's not crack. The complement. So that will be C complement. So what will be the value here? On this
0.
branch?
0.995.
0. Right now. I need to get a mouse. So let me erase that. It's gonna be 0. Point. What is mentioned?
995, sir.
995. 0.995. Anyhow, yeah, like that. So everybody could more or less figure out what numbers are those, right?
Yes,
Sure,
sir.
sir.
Yes, sir.
Okay. Now they're asking, let's see, what is the probability that a brick chosen at random is cracked? So let me just copy this for now. Okay, what I will do, because I will still need to extend the diagram here, and let me put that in right away, because it says here that given that discoloration occurs independently of the other two defects, find that the brick chosen at random has no defect. So that would have been the last branch, meaning that it doesn't have a bubble. Let me put on my highlighter. No, that's not a highlighter. Okay, you see the other thing going? So here, this is showing that it is free of air bubbles. This is showing that it isn't cracked. So I don't need to pull up the other branches. So all I need to do is to put in the one with the discoloration. Let me put that in. Because only the last branch we need. So I will put my branch right here. So and then this will be here. Then it said that for discoloration, that it's D. So for it not to be discolored, then that will be the complement. Like that. So we mentioned that given that discoloration, right here, the probability that a brick is discolored is 0.006. Given that discoloration occurs independently of the other two defects, find that a brick chosen has at random has no defect. Okay, so here is gonna be, we're gonna put in our values. So that will be 0. Point 0 0 6. Okay, so if that is 0.006, then below here would be what?
0.994.
0.994.
Yes, sir.
Okay. So 0.994. Let me copy this now. Then I will minimize this. I will come here. Now we have done our tree diagram. Okay. So I have it here. Then it's asking here, what is the probability that the brick chosen at random is cracked? Now, like I told you, we could go to each end and see. So we're gonna be, I should have actually have, so we're gonna be going branch by branch and up to this branch here, but we don't need to do all branches. All it's saying here, what is the probability that a brick chosen at random is cracked? So from what I can see, I have the first here, right? The first branch, and what other branch? The third one, first and third. Everybody agrees?
Yes, sir.
Okay, good. So the probability, they mentioned the probability that it is cracked. So in this case, that's the first part. So if you notice, let's give that an event. PD, the probability of B. I haven't used B yet. And we are using B that it is the probability that it is cracked. Now, we're gonna be using the first branch, so let's write the notation that will be the probability of what? Before putting figure, the probability of A intersecting what? Are you still hearing me?
Complement.
C plus the probability, then we go to the other branch here to show where it's cracked. That's the third branch. So that will be A complement intersecting C. So that will be the probability of A complement intersecting C. And this will be A complement. And then here we close our bracket. Everybody see what's happening here? So now we're gonna be looking at values. So the probability will be equals, now we're gonna be putting I will show the work in there because I didn't show it on the branches because it will take me time. That these should have been at the appropriate branches. Like what I have here, the one that should be shown here, probability of A intersect C. So we just add them up and that's it, but I'm gonna be doing it here. So that will be so in here, we're gonna have 0.002 and 0.5. Remember that. 0.002 and 0.5. And then for the third branch here, it will be 0.998 times 0.005. So in this case, I want values now. I need assistance. I want you to give me the values of the products. So the probability of B is equal, what is the first product? 0.002 times 0.5?
0.001.
0.001. Okay, plus what will be the other product?
You give me wait, my answer is wrong, I guess.
Just give me everything that you have there. Do it again, 0.998 times 0.005.
Give me 0.0049.
0. Point,
That is correct, Elvis.
0.
Okay,
Point, 0. Point,
049.
like that?
It's another zero, sir. 0.0049.
Okay, exact.
Exactly.
Okay. So when we add these together, then what would we get?
0.0059.
Okay, so the probability of B, and remember that was the same answer we got when we were doing by calculations. So it's gonna be 0. Point what?
0.0059.
9?
Yes, sir.
Okay. Now, the next one is saying here, given that discoloration occurs independently of the other two defects, find the probability that a brick chosen at random has no defect. So, what branch will that be? What branch is showing that there is no defect? Here, we have noticed this one is free of air bubble. That's no defect. Here, no crack. Here, no discoloration. Actually, I put the D complement here and I forgot to put the so remember this is D complement. Let me see if I could. don't think I could put it at the complement there.
そんなわけないだろう。相手は学校のマドンナだぞ。失礼。すごい失礼。
So remember, this should be the complement, okay? Is that clear to
Yes, sir.
everybody?
Yes, sir.
I didn't know. Nobody did. I don't like that there though. Let me see something here. If I could go back and do it, copy it, and then take it back here, right here. So this would have been the complement. I don't like those type of work. Edit, copy. So what I will do, I will get rid of that and put in the new one. Okay, so there it goes. So it's gonna be the last branch. So that will be A complement, intersecting C complement, intersecting D complement. So let's call that the probability of, we have D already, the probability of G. So the probability of G will be equals to the probability of open bracket A complement intersecting C complement intersecting what? Let me see if you're following.
The complement.
Okay, the complement. So this is P of air bubble isn't cracked and isn't discolored. So we need to get our values there. So the probability of G, remember the G will be the event that it has no defect. So that will be 0. Somebody write this so that you give me 0.998 and then 0.995 and then 0.994. Write that and then you give it to me right now. So what is the first value?
0.998, sir.
998 plus 0.995
995.
995 plus
994.
Okay. And it's not positive here. I made a mistake. This should be what? Multiplication. Remember, these are independent events. Okay. Multiply them out for me and tell me what you get.
0.987.
Okay. So just remember that value. Let me just put this in.
Every time.
What will it be?
987, sir.
0.987. 7. And if you notice, we got the same answer like when we were calculating it, right?
Ahorita nos vamos con
Remember?
esta cosa.
So I'm hearing somebody. People, your mics. Right. So the one that we did last time, by calculation, let me see. When we were doing it by calculation, see, these were the one, and we have done all of these by the probability tree. You should get the same answers. See, this one we get 0.24, this one we get 0.18. When we add it, our answer was 0.42. Or the ice cream. These are by calculation. Then this one was by the pen. Oh, I didn't do the one with the pen. But that is very interesting. Then we have this one that we did by calculations. We obtained, because then what will happen there? We did the two, then we add them, and we get 0. In this case, 0.00599. So which means then that, and then the other defect is 0.986. So, yeah, I already see what happened there. Because due to the methods that we use, but it's same, it is 0.0059 this one has, and then this other one 0.987, which is the same answer. Because this one, some people mentioned it's 0.0049. The other one we got 99. So if you multiply this 0.998 by 0.05, here we got 0.0049, and here 0.00499. But when we multiply that, given that, which will be 0.05, and what we got. So which means then 0.05 given, yep, that's 0.005. It's 0.005. And we have that on the brick. Let me see. I'm just cross checking on the tree. Yeah, we have it there too. So nothing's wrong with it. Like I said, it's the answer is the same thing, only because one has a extra digit, but it gave you the same answer. Any question? Any questions?
No, sir.
Okay, since there are no questions, we're gonna be stopping there today. And like I said, tomorrow, by tomorrow you're gonna see it uploaded there. And with the names of the students. Well, everybody needs to do, so I don't need to put, because it's not a group. So I will just be uploading the 5 questions that you need to do. And remember, these will be done by means of calculations. You won't be using a tree diagram. You put in any tree diagram there, and there will be one that I'll be asking you to do a tree diagram, one of them. But the rest, I want it to be done by means of strictly calculations. Is that clear? Is that clear to everyone?
Yes, sir.
Okay, so I will be seeing you all. Enjoy the rest of the day.
Sir,
Yes.
but we can use the tree diagram to help us, right?
Yeah, you could use the tree diagram to assist you, but remember, yes, you could use it to see if your answer is correct or not. But then I don't want to see any tree diagram for the one that I didn't see a tree diagram.
Okay, sir.
You
Thank you.
understand? Okay.